Hello, this is Mr. Collier, and today we're finding points on a curve given the gradient or given the derivative. So we're kind of working backwards today. Here are some steps to follow. We're going to differentiate. We're going to make the derivative equal to the gradient, solve for x, and then we have to substitute into the original function and find the y-coordinates. So we have the coordinates of the point. Okay, so point A lies on this curve, and the gradient is 1. Find the coordinates of point A. So that curve is going to be a parabola, and a tangent line with a slope of 1 is probably going to be right here somewhere on the parabola. So we're given the slope of the tangent line. We got to find this point. Okay, so we can do that. First of all, we have to differentiate. We have to find the derivative. So we're going to have dy by dx equals, and we differentiate this function, we're going to have 5 minus 2x. Okay, so we've got the derivative. Now we have to make the derivative equal to the gradient. So we know that the derivative at this point is 1. Okay, we know the derivative at that point is 1. So we're going to set this equal to 1, so we're going to have 1 equals 5 minus 2x, and then just solve for x. So we have negative 4 equals negative 2x, and divide by negative 2. We're going to get x equals 2. So we know now that the x coordinate here is going to be 2, and then we have to find the y coordinate. Okay, so actually we just already solved the equation right there. So we're going to find the y coordinate. Well, we have the x coordinate. Our original function is 5x minus x squared. So y equals 5x minus x squared is our function. We know x equals 2, so we're going to have y equals 5 times 2 minus 2 squared. And we'll just work that out, 10 minus 4, which is 6. So the point is 2, 6. So if we look at our sketch of the graph, this point here is going to be 2, 6. Okay, so given the slope of the tangent line, we can find the point at which it touches the original curve. So in the next example, we have a cubic function, and we're given the gradient is negative 2. Find the coordinates of the 2 points. So in cubic, it kind of looks like this. So you can actually have the same slope of a tangent at 2 different points. So you could have, like, say, here and here, maybe they're the same slope. Maybe even here and over here, they could have the same slope. So if you're given the gradient, there's possibly going to be 2 points with the same slope. Like, look at this one. Here the slope is 0. Oops. And here is the slope of this tangent is 0. So there's two points where the slope is 0. So we're going to find the coordinates of these 2 points. First we have to differentiate, of course. So we're going to find dy by dx, the derivative, which is 3x squared minus 18x plus 13. So we have that, and then we've got to find the coordinates of the 2 points at which the slope is, negative 2. So then we substitute in negative 2. We know the slope is negative 2, so we substitute that in. And we get this. Okay, now we could we should get 0 on one side. We want to solve this quadratic. We can get 0 on one side, and we can do this with our calculator. Okay, so we go to apps. Go to polysmalt 2. Alright, so I'm going to press enter here. So we go to poly root finder. Okay, so it's already set on order 2. That means a polynomial with the highest power is x squared. Everything's ready to go. I'm going to click next. And I'm going to type in the numbers here. So we have 3, negative 18, and we have 15. Okay, I got all that typed in. Then I click solve. We have x equals 1 and x equals 5. X equals 1 and x equals 5. So those are just the x values. We know our 2 points are going to be 5 and then some y value. and 1 and then some y value. So we need to substitute those into the equation to get the actual points now. So we're going to have y equals 1 squared, minus 9 times 1 squared. Let's do this actually. Let's do this down here so that's more room. So the original equation is y equals x cubed, so we're going to do 1 cubed minus 9 times 1 squared plus 13 times 1 minus 2. You could work that on the calculator if you want. This is 1 minus 9 plus 13 minus 2. So that's negative 8 plus 13 is 5. 5 minus 2 is 3. Okay, so that means that with the 1 point is going to be 1, 3. And now let's work at the other one. Y equals 5x, or 5 cubed minus 9 times 5 squared plus 13 times 5 minus 2. So let's work that one on the calculator. So I need to quit out of there and go just do 5 cubed minus 9 times 5 squared plus 13 times 5 minus 2. We get negative 37. Negative 37. So the other point is going to be 5, negative 37. Okay. So we've got all that. Now we got to find the equation of the straight line through those 2 points. So if these are the 2 points, then we can draw a line through the 2 points. Okay. So let me just do part B in red here. So we have 2 points. We want to get the equation through the 2 points. We can first of all get the slope between those 2 points. Slope equals y2 minus y1 out of x2 minus x1, which equals negative 37 minus 3 out of 5 minus 1, which equals negative 40 out of 4, which equals negative 10. Okay, slope is negative 10. We can find the y-intercept now. So we know the equation line is y equals mx plus b. So y equals negative 10, x plus b. And then we can substitute in one of the points. I'm going to pick this one here to sub in. So I'm going to have 3 equals negative 10 times 1 plus b. So 3 equals negative 10 plus b, and we add 10. We get 13 equals b. So our final answer for the equation of a straight line is y equals negative 10 x plus 13.